Hello everyone. In the previous lecture, we have seen one example on the subspace. Now if suppose question is show that W is a subspace of R cube. So here most of the cases when it's a question of show that it has to be a positive result. It will be always a subspace. But sometimes question is asked check whether a given set is a subspace or not. So in that case, the given set can be a subspace or it cannot be a subspace. So always remember, if any set is not subspace, so it's just sufficient to prove whether one of the condition is failed or not. Right? So to prove that any set is not a subspace, it's sufficient to show that any one of the three condition fails. So based on this, now I am taking one example. So question is check whether W equal to the set. Again, it's a triplet x1, x2, x3 belongs to R cube. That is, it's a member of three-dimensional space such that x1 plus x2 plus x3 equal to 1. Check whether this is a subspace of R cube. So remember one thing, whenever you have a linear expression as a condition, so my variable terms are here x1, x2, x3, each of them has a power 1. So whenever a linear expression is here and right hand side is non-zero term, then the result goes on the negative sign. That is, it is not a subspace. Why? So I will show here why. So given W is this. So let us write what does it mean. So what are the elements of W? Elements of W are in the form of triplets. So x1, x2, x3 belongs to W. When it belongs to W, if it satisfies the condition that x1 plus x2 plus x3 is equal to 1. So when we have addition of all three components of this vector quantity as 1, then we say that it's a member of W. Let us call it as equation 1. So here, as I said, it's a linear expression and their sum is not equal to 1, is not equal to 0. Okay, not equal to 0. So in this case, the result comes out to be a not subspace. Why? Because if I'll take a 0 element, right? So 0 element does not belongs to W. Why? Because if we add these three elements, so as per the result, what we get 0 plus 0 plus 0 is equal to 0. Whereas the requirement is it should be 1. And we know that 0 is not equal to 1. So that's why 0, 0, 0 does not belongs to W. So as 0 elements does not belongs to W, so first condition fails. So we need not have to verify the remaining condition. Here itself we can declare that W is not subspace. W is not subspace of R cube. So I hope concept is clear to all. So how will you show that it's not subspace? So for proving that a set is not subspace, it's sufficient to mention that one of the condition required for subspace fails. Let's have another example. Suppose now I am having the set as say W is equal to, set can be represented by any alphabet, maybe W, S, U, V as per your choice, right? So here I am taking verify whether W is equal to the set say XYZ. such that, what is the condition? X square plus y square plus z square less than or equal to 1. So check whether W, a subset of V3 of R is subspace of V3 of R. Now, what does it mean by here V3 of R? So here V stands for vector space, 3 stands for third dimensional, and R stands for real number. So it's a vector space whose elements are real number and it is of 3 dimension. Is the meaning of V3 of R. So again, given W is this, that is W is containing a triplets. Here you can see the triplets are denoted by XYZ. So we can have XYZ, or we can have ABC, or it can be X1, X2, X3. Any notation can be taken, right? So W is containing a triplets. What type of triplet it contains? Those triplets where if I take the square of each component and if we add them, so the resultant should be less than or equal to 1 is the meaning of this. So what type of element belongs to W? So that we'll write here. So given what type of elements belongs to W, first of all it should be a triplet, that is XYZ belongs to W, and what is the condition required is x square plus y square plus z square is less than or equal to 1. This is what is mentioned here in the definition of W. Now, we want to show or check whether it's a subspace of V3 or of R or not. So let's verify first condition. Let us take 0 element of the triplet, that is 0, 0, 0. So, will it belongs to W? So, answer is yes. Why it belongs to W? Because if I take what square of each component, 0 square, then 0 square, and then 0 square, and if we add them, so it comes out to be 0, and this 0 is obviously less than or equal to 1. That's why 0 belongs to W. So first condition gets satisfied. Let's go for second condition. Second condition says that we need to select 2 elements of W. So let us take first element as U, which I am denoting as containing a triplet x1, y1, z1, and second element is V, which is another triplet x2, y2, z2. So U and V both are elements of W. So as per equation 1, as these U and V are elements of W, so it should satisfy this condition. So equation 1 implies the square of each element, that is x1 square, y1 square, z1 square, and their addition must be less than or equal to 1. Similarly, x2 square plus y2 square plus z2 square is less than or equal to 1. So this is what we have because U and V are W. Let us call this condition as equation number 2. Now what is our aim? Our aim is here, as per the second condition, to show U plus V belongs to W. This is what we have to show here. Now, so let us first find out what is U plus V. So U plus V is, it's a usual vector addition. So U is x1, y1, z1, and V is x2, y2, z2. So we will add their corresponding elements. So it will be x1 plus x2, then we have y1 plus y2, then we have z1 plus z2. Right? Now, what we want to show, that U plus V belongs to W. So for this, we'll take the square of each element and then we will add them. So x1 plus x2 whole square plus y1 plus y2 whole square plus z1 plus z2 whole square. Now consider this. Now as we see square of the addition of two terms, so we will use the expansion formula. So according to that, it will be x1 square plus 2x1 x2 plus x2 square plus similarly expand remaining two terms. So it is y1 square plus 2y1 y2 plus y2 square. And then we have z1 square plus 2z1 z2 plus z2 square. Always remember, in order to prove certain results, we always make use of the given quantities. Right now, the given quantities are equation 1 and equation 2. This is what we can use here. Right. Here, as per the result, what we will do? We will collect x1 square plus x2 square plus x1 square plus y1 square then plus z1 square and then plus x2 square plus y2 square plus z2 square, and then there are few extra terms also. What are they? It is 2 times x1 x2 plus y1 y2 plus z1 z2. Okay, now you can see here the value of this is less than or equal to 1 as per equation number this, right? Similarly, the value of this term is less than or equal to 1. So we will put the values here. So it is 1 plus 2 times x1 x2 plus y1 y2 plus z1 z2. So in none of the cases this won't be less than or equal to 1. It will be more than 1, right? So therefore u plus v does not belongs to w. So as u plus v, first condition is satisfied. What was the first condition? 0 element is a member of w. But now second condition is not satisfied. As soon as one of the condition is not satisfied, so we are free to declare here that the given set is not a subspace. So W is not a subspace of V3 of R. So I hope everyone must have understood how to check the condition and make the statement whether a given set is a subspace or not. So in the next video, we shall see few more important example on the subspace where we will not consider any tuples, but we will consider a matrix space or any other vector space. Thank you all for watching the video.